Welcome, CSEC Chemistry, June 2022, Paper 2, Questions 1 to 3. Share and subscribe for more upcoming content. Let's begin. Question number 1. An experiment was carried out to determine the energy change for the reaction of magnesium metal and hydrochloric acid. The procedure is given below. During the procedure, the temperature was recorded every 15 seconds for 2 minutes. Here is the first 5 temperature readings taken during the experiment. A. Part 1. Complete Table 1 by recording the temperature readings shown in Figure 1. At 15 seconds, the temperature is 33 degrees Celsius. 30 seconds, that will be 39.5 degrees Celsius. At 45 seconds, the temperature is 43 degrees Celsius. 60 seconds, that is 44.5 degrees Celsius. And at 75 seconds, the temperature is 46 degrees Celsius. Adding the data to the table in A Part 1. Part 2. Using the grid provided on page 7, plot a graph of temperature against time using the data in Table 1. Draw the best curve through the points. Okay, so now we're on page 7. First, I will be labeling the axes, so that's Y, and then the x-axis. Based on the temperatures, we have to deduce which lines represent 1 degree Celsius, 2 degrees Celsius, etc. The scale on the y-axis is 2 centimeters to 5 degrees Celsius. Therefore, every 2 small spaces represents 1 degree Celsius. So this is 0, 2 small spaces above 0, 1, 2 small spaces above 1, 2, 2 small spaces above 3, 2 small spaces above 4, and there you go, 5 degrees Celsius. First, find 0 seconds on the x-axis, move up the y-axis to 25 degrees Celsius, point and circle. 15 seconds on the x-axis, move up the y-axis until you are at 33 degrees Celsius, dot and point. 30 seconds on the x-axis, then you move up that line to 39.5 degrees Celsius. So now we're going to put a dot and circle it. 45 seconds on the x-axis, move up to 43 degrees Celsius. Put a point, and then we're going to circle it. You are going to continue plotting all the points on the graph. At this time, we are drawing the best curve through the points. Part 3. Using your graph, determine the temperature change for the reaction. The temperature change is the difference between the highest and the lowest temperature. Therefore, 46 degrees Celsius, highest temperature, minus 25 degrees Celsius, lowest temperature, equals 21 degrees Celsius. Part 4. State one difference between endothermic and exothermic reactions. A difference is heat is absorbed by the system for endothermic reaction, while for exothermic reaction, heat is released by the system. Another difference is for endothermic reaction, temperature of the surrounding decreases, while for exothermic reaction, temperature of the surrounding increases. Part 5. State whether the reaction between magnesium and hydrochloric acid is endothermic or exothermic. The reaction is exothermic since there is an increase in temperature. B. Part 1. Write a balanced chemical equation including state symbols for the reaction between magnesium metal and hydrochloric acid. Metal reacts with acid to produce salt and hydrogen gas. Therefore, the equation will be magnesium solid plus HCl hydrochloric acid to produce a salt, magnesium chloride, MgCl2 aqueous plus hydrogen gas, H2 gaseous state. This equation is not balanced since there is one chlorine on the reactant side while two chlorines on the product side. Also, there is one hydrogen on the reactant side and two hydrogens on the product side. In order to balance this equation, we are going to add the numeral or coefficient 2 in front of the hydrochloric acid. Part 2. Calculate the number of moles of magnesium used in the reaction. The relative atomic mass of magnesium is 24. For this calculation, we must use the mass of magnesium used in the experiment. Based on the procedure, 0.48 grams of magnesium was used. 1 mole of magnesium is 24 grams. Now the unknown X gives 0.48 grams. First, we are going to cross multiply. X equals 1 mole multiplied by 0.48 grams, and this will be divided by 24 grams. X equal 0.02 moles of magnesium used in the reaction. Part 3. Determine the volume of gas that would be collected if the reaction took place at STP. The molar volume at STP equals 22,400 cm3. Based on the reaction, the mole ratio between magnesium and hydrogen is 1:1. Hence, the mole of hydrogen is 0.02. Since 1 mole of hydrogen gas occupies 22,400 cm3, 0.02 mole of hydrogen occupies X cm3. So we are now going to cross multiply. X equal 0.02 moles multiply by 22,400 cm cube divided by 1 mole. The answer is X equal 448 cm cube of hydrogen gas. C. Part 1. Calculate the energy change for the reaction between magnesium and hydrochloric acid. Assume the specific heat capacity of the solution is 4.2 joules per gram per degree Celsius and the density of the solution is 1 gram per cm cube. The energy change equals mass multiplied by specific heat capacity, C, multiplied by the change in temperature. Based on the experiment, the mass of the magnesium is 0.48 grams and the mass of hydrochloric acid is 100 gram. 100 gram is the same as 100 cm cube. Hence, the change in energy equals 100 gram plus 0.48 gram multiplied by 4.2 joules per gram per degree Celsius multiplied by 21 degrees Celsius. Thus, 100.48 grams multiplied by 4.2 multiplied by 21 degrees Celsius. The gram will cancel the per gram. The degree Celsius will cancel the per degree Celsius, and this leaves us with the unit joules. The energy change equals 8,862.336 joules. Part 2. Hence, determine the energy change per mole of magnesium. 0.02 moles of magnesium is 8,862.336 joules. 1 mole of magnesium equals X. First, we're going to cross multiply. X equals 1 mole multiplied by 8,862.336 joules. This divides by 0.02 mole. X equal 443,116.8 joules. This is equal to 443.1 kilojoule. Since this is an exothermic reaction, the value must be negative. Therefore, X equal negative 443.1 kilojoules. Question number 2. A. Steels are alloys widely used in industry in place of iron metal. Part 1. Define the term alloy. An alloy is a mixture of a metal with one or more other elements, normally another metal or metals. Part 2. Name 2 types of steel: stainless steel, carbon steel, tool steel, alloy steel. So there you go, 4 types of steel instead of 2. Part 3. State two enhanced properties of steel. Enhanced properties include resistant to corrosion, increased hardness, withstands high temperatures, and increased strength. B. Many metal nitrates undergo thermal decomposition. The relative ease of decomposition and the products formed can help determine their place in the reactivity series. Table 2 below shows the products formed from the heating of the nitrates of 5 different metals V, W, X, Y, and Z or Z, respectively. Metal nitrate V, X, and Y form products metal oxide, nitrogen dioxide, and oxygen, while metal nitrate W and Z products are metal nitrate and oxygen. Part 1. Using the information from Table 2, state which metals would be the more reactive metals and which metals would be the less reactive metals. Based on the products formed for each metal nitrate, W and Z would be the more reactive metals, while V, X, Y would be the less reactive metals. Part 2. If one of the more reactive metals was identified as sodium, write a balanced chemical equation for the decomposition of sodium nitrate. Since sodium is a more reactive metal, the equation will be sodium nitrate NaNO3 solid decomposes to form sodium nitrite NaNO2 solid plus oxygen gas. This equation is not balanced since there are 3 oxygens on the reactant side while 4 oxygens on the product side. Therefore, in order to balance this equation, we are going to write the coefficient 2 in front of the sodium nitrate and 2 in front of the sodium nitrite on the product side. Part 3. Further tests were carried out with metals V, X, and Y. Each metal was the oxides of the other metals in displacement reactions. V did not react with any of the metal oxides. X react with the oxides of metal V and metal Y, successfully displacing the metals. Y reacted with the oxide of metal V, successfully displacing the metal. Use this information to deduce the order of reactivity of the metals V, X, and Y from the most reactive to the least reactive. Since metal X displaces metal V and Y, X is the most reactive metal. So we write X and then write the greater than sign. Y would be next in reactivity since it reacted only with the oxide of metal V. V would be the least reactive metal since it did not react with any of the metal oxides. C. Tests were carried out on solution A to determine the cations present. The observations are presented in Table 3. Complete the table by inserting the inferences based on the observation. Now the first test, a few drops of dilute sodium hydroxide were added to a small portion of solution A in a test tube. First observation, green precipitate formed. Second observation, green precipitate darkened when left to stand and turned orange at the top of the test tube. Based on the reaction, Fe2+ ions are present. The equation will be Fe2+ aqueous plus hydroxide ion aqueous combine to form iron hydroxide, which is a solid. This equation is not balanced. In order to balance this equation, we are going to write the numeral or coefficient 2 in front of the hydroxide ion. Second test. A few drops of dilute sodium hydroxide were added to a small portion of solution A in a test tube. The test tube was heated gently. First observation, colorless gas evolved with a pungent odor. Gas turned damp red litmus paper blue. Second observation, colorless solution formed. Inference for the first observation is that ammonia gas is produced. Also, there are ammonium ions present. The equation would be ammonium ions aqueous plus hydroxide ion aqueous to produce ammonia gas and liquid water. Question 3. Figure 3 shows compound A and compound B, which are from different homologous series. A. Part 1. State the homologous series to which compound A belongs. Compound A has a carboxyl group, therefore it belongs to the alkanoic acid or carboxylic acid homologous series. Part 2. State the functional group of compound A. The answer, carboxyl group. Part 3. State the name of compound A. First, number the carbons starting from the functional group 1, 2, 3, 4. So since there are 4 carbons, the prefix is bute. Therefore, the name is butanoic acid. Part 4. State whether compound A will undergo a condensation reaction or addition polymerization reaction with alcohols. The answer is condensation polymerization. B. State the homologous series to which compound B belongs. Since compound B has a double bond between two carbons, the homologous series is alkene. Part 2. Write the functional group of compound B. The functional group is double bond between two carbons. C double bond C. Part 3. State the name of compound B. First, number the carbons starting from the double bond. 1, 2, 3, 4. Since there are 4 carbons, the prefix is bute. Hence, the name is butene. C. Figure 4 shows compound C, which has structural isomers. Part 1. Define the term structural isomers. Structural isomers are compounds that have the same molecular formula, which is the same type and amount of each atoms, but different chemical structures, which is different arrangement of the atoms. Part 2. Draw the fully displayed structure of the two structural isomers of compound C. Compound C has 5 carbons and 12 hydrogens. Here are 2 isomers. Part 3. Write the names of the 2 structural isomers you have drawn in Part C 2. First, number the longest chain. 1, 2, 3, 4. There is a branched group which I'll circle. Since there are 4 carbons in the longest chain, the prefix is bute. The compound only consists of single bonds, therefore it's from the homologous series alkane, so the name will be butane. Since there is a methyl group attached to carbon 2, the name will be 2-methyl-butane. You must write a dash or hyphen between the numeral and the word. Naming isomer 2. First, label the longest chain. 1, 2, 3. Now there are 2 methyl branch groups, which I'm going to circle. That's 1 and 1 above. There are 3 carbons in the longest chain, so the prefix is prop. Since there are only single bonds, the name will be propane. There are 2 methyl groups. We write dimethyl. Both of them are attached to carbon 2. You must write the numeral 2 twice, one for each methyl group, and the numerals should be separated with a comma. Therefore, the name of isomer 2 is 2,2-dimethyl propane. Questions 4 to 6 will be posted shortly. Thanks for watching. Share and subscribe for other content and questions 4 to 6. All the best.